So we've looked at many important aspects of models and what the models can possibly tell us. We are now going to look at an extremely important part of statistical analysis, and that is the use of multiple explanatory variables. Up to now, the models we have looked at all had just one explanatory variable and, of course, one outcome variable. Now we are going to see that when we bring in more explanatory variables, the picture starts to become clearer and clearer. So we look at multiple explanatory variables. Our example comes from a real life scenario where at some point in time, somebody analyzed an op-ed writer actually to a large newspaper. They, they analyzed the data of various states and the amount of money that they spend per student on education. This is high school education. And they related that expenditure to the average SAT scores of those states. So here, every point represents a single state, and they essentially looked at how much money each of the states is spending per capita on students and what the average SAT score of the students is. Okay. Now, of course, the relationship they saw was that the states that seem to be spending more per capita on students were actually having lower average SAT scores. Okay, so they actually saw this to say that somehow spending more money on school education causes the states to have lower SAT scores. Okay, so as I've said, the unit of observation here is the state, the explanatory variable is the per pupil expenditure, and the response variable or the outcome variable is the average SAT score of the state's students. Okay, and they came to the conclusion that spending more money causes students to actually perform poorer in SAT scores, and they said, look, our model is actually showing that. Okay, so we want to examine, is there really a relationship between per pupil expenditure and SAT scores whereby higher expenditures mean poorer SAT scores? Or, of course, is the more strong statement that was made along with this op-ed that higher SAT expenditure, higher per pupil expenditure somehow causes the SAT score to fall. Okay, so now we think, okay, what other variables in their data set might be having an effect on SAT scores? So one thing that they found was that there was a variable which represented the percentage of students in each state who participate in SATs. Okay, now not all states have almost universal participation in SAT. For example, in New Jersey, almost every high school student writes the SAT. Very few high school students don't take the SAT. Whereas there are other states where only a very small percentage of students take the SAT. Okay, so some researchers looked at the relationship between participation percentage and the SAT scores, and they found that states where there's a high level of participation in SAT have lower average SAT scores. Okay, now this is understandable, right? Because if you have states where the participation in SAT is very low, okay, what that means is that the people who are participating in SAT may be the students who are aspiring to get into good universities, and therefore they might be the motivated students, and therefore naturally there is a level of self-selection that good students are the ones who are taking SAT, and the other less motivated students are not even taking the SAT. And therefore, naturally, when you have self-selection like that, states where the participation in SAT is low in terms of percentage, in those cases, it is the highly motivated students who are taking the SAT, and naturally, their average SAT scores are going to be higher. Because the students who are not taking the SAT, we are not including them in computing the average of the SAT scores. So for states with lower participation, you're taking the average SAT scores of students who are more motivated. And for states where participation in SAT is very high, okay, there you're taking the average SAT score of a much wider student population, and therefore the average is likely to go down. Okay, so we now have two conflicting things, right? If you look at expenditure versus SAT, you're seeing that as expenditure increases, SAT is going down. And then when you look at participation versus SAT, you're seeing as the participation increases, the SAT score is going down. Okay, so the reality is that the states where the participation in SAT is higher, states like New York and New Jersey and California, those are the states that actually tend to spend more on education as well. Okay, so it's not as if somehow expenditure is causing the SAT score to come down. It is that it is just coincidental that those states with higher participation in SAT are also the ones who are spending more money. And probably it is participation that is explaining the change in SAT scores. Okay, so this is what we just saw. There's self-selection and all of those things that we just discussed. Okay, so let's look at let's bring in one more variable into the picture of the plot of expenditures versus SAT scores. Okay, so if you bring in the fraction, which is the participation, the percentage of the state's students who participate in SAT, if you bring that into the picture, okay, then what we are seeing is that actually as the expenditures increase, you're seeing that for various levels of participation, the SAT score is actually increasing. Okay, now notice that because we put the fraction of participation, a numerical variable, as an explanatory variable, what the point plot function actually did was it said, okay, the fraction between 4 to 11 is indicated by this color, 11 to 48 is indicated with this color, and 51 to 80 is indicated in this color. I assume there's no state between 48 and 51. Okay, so if you bring that new variable into the picture, it tells a very different story, that higher expenditures actually mean higher SAT scores. Okay, however, we have to be a little careful, okay, in the sense that uh, these bands are almost horizontal. Okay, which means that a horizontal line will fit into each of these bands, even this band. Okay, and that tells you that even though you're seeing a relationship that higher expenditures actually show higher SAT scores, this is not statistically significant, and we cannot use this to say uh, with great confidence that expenditures have a connection with SAT scores. Okay, however, this is indicating that there is a higher trend. Okay, let's plot the chart slightly differently. Let's plot participation versus uh, per pupil expenditures. And we are clearly seeing that states where the participation is higher are the same states where the per pupil expenditure is also higher. And onto that plot, let us bring in the expenditure. Okay, which is here we are saying participation percentage with SAT, and we saw this earlier that higher the participation, lower the SAT, average SAT score. And onto that, let's bring in the expenditure. Okay, so clearly now we are seeing that there is a strong relationship between participating and SAT, and it's also telling us that states with higher expenditures, uh, that at every level of expenditure, we are seeing that there is a relationship between participation and SAT scores. Okay, so from all of this, we can infer that what is explaining the change in SAT scores is not expenditure but participation. Okay, so this is something that you will see quite often in statistical analysis. People will do some sort of simplistic analysis and try to make a case for something, but a more sophisticated analysis can actually show you that what they are talking about is not completely correct, right? And there are other explanations for the phenomena that we observe. This is a very important aspect of critical thinking. And that is why using multiple explanatory variables is very important in statistical analysis. Okay, so which model should we use? Should we use the model that just says uh, connects SAT with expenditures? Clearly not. We can see that the model that the moment you bring in participation and expenditures, then you see a much more nuanced picture. Okay, so later in the course, we'll be looking at quantifying the explanatory power of uh, explanatory variables. Okay, and we'll also see which model is the more appropriate one. Obviously, in this case, this second model seems to be the more appropriate one. And of course, when you're looking at causality, especially, you need more sophisticated models to really establish what caused what.